Okay, so today we're learning the parent functions of the square root function y equals the square root of x, what that looks like. Okay, the reciprocal function y equals 1 over x, and the absolute value function y equals the absolute value of x. Okay, we're going to learn what an asymptote is again. We talked about it yesterday, and we're learning how to do simple absolute value functions. All right, so some parent functions we already know from grade 9 and 10, okay? The parent function can be thought of as the simplest version of a category of functions. So like the simplest line or the simplest parabola, okay? The linear function or the line, its parent function is y equals x, or you could say f of x equals x, okay? So if these are my x values, and y equals x, if x is -2, y is going to be -2. If x is -1, y is going to be -1. And that's because we're looking at the simplest function, which is y equals x. Whatever x is, y is as well. And if we plot those points, you're going to get a line with a slope of 1. Goes right through 0. That's considered to be the most basic line. And we want to say its domain and range. So its domain, all real numbers, and its range, lowest to highest, all real numbers. Okay. Okay, the next one is the parabola. So parabola is a function. The most basic parabola is just y equals x squared, or using function notation, f of x equals x squared. So I take x and I square it to get y. So -3 squared is +9. So the negative times a negative is positive. -2 squared is 4. -1 squared is 1. Okay, and then if we draw that, -3 and 9, -2 and 4, -1 and 1, 0 and 0, 1 and 1, on a smooth curve. Because some of you did grade 10 by remote learning, we'll just recap a few of the important features about a parabola. This point here is called the vertex. Does that seem familiar to people? Okay. And then the step pattern is how you get from the vertex to the next point on a corner. So we go over 1, up 1. Okay. So our step would be up, because we're going upwards, and our first step up is 1. Our second step up is 1, 2, 3. Our third step up is 1, 2, 3, 4, 5. And if we had room to keep going, it would go 7, 9, 11. Okay, that's our step pattern. So up 1, 3, 5. Okay. And then this line here, that the parabola is symmetric around, that goes right through the vertex, is called the axis of symmetry. It's not part of the parabola, but it's something you talk about when you talk about parabolas, and really it means that, see these 2 points, they're exactly the same distance from the axis of symmetry. these two are exactly the same distance from the axis of symmetry. So if you fold the parabola in half over the axis of symmetry, the two sides line up on top of each other. Okay? That's what the axis of symmetry is. All right, so those are basics of a parabola. If you didn't quite catch on to them last year, what would be the domain and range, do you think, of that parabola? Good.
That can be any real number.
Yeah.
It can be any number greater than or equal to 0.
Very good. There's our domain and range. Perfect. So those are ones we know from grade 9 and 10. Now we're going to go on to new ones that we don't know yet. So the square root function, which I call the half parabola on its side, okay? The parent function is y equals the square root of x, or you can write it as f of x equals root of x using function notation, okay? So you notice I didn't fill in the x values because I want to think them through. So first of all, can you take the square root of a negative number? You try it on your calculator. If you try to take the square root of -2, you get error. Okay, if you're not convinced, try it. So the first number you can take the square root of is 0. And the square root of 0 is 0. The next number that you can take the square root of where it gives you a whole number is 1. The square root of 1 is 1. What's the next perfect square after 1? 4. Correct. Okay. Square root of 4 is 2. So that's 0 squared, 1 squared is 1, 2 squared is 4, 3 squared is 9. Square root of 9 is 3. And then 4 squared is 16, and the square root of 16 is 4. Okay? So let's see what this looks like. So we'll start off plotting 0, 0, which is down here. And then 1, 1. And then 4, 1, 2, 3, 4, 2. And then 9, 3. We can't fit 16, 4 on. But there's our square root function, half parabola on its side. So it doesn't have a vertex, but it has what we call a starting point. And it's got an arrow, it keeps going in that direction. But the other thing that makes it a half parabola on its side is its step pattern. So we go over 1, up 1. So here, my over is 1. To get to the next corner, I go over 1, 2, 3, up 1. Okay, so my overs are 1, 3, and 5. Then I go over 1, 2, 3, 4, 5, up 1. And if I had room, I'd go over 7, up 1. Okay, so it's over 1, 3, 5. Okay, and up 1. Okay, so it is really a half parabola on its side. So looking at that, see if you can figure out what its domain would be and what its range would be. That's the square root function. Anyone for domain? Yep.
X is a number of the reals
Yep.
as long as it is greater than or equal to 0.
Perfect. And the range?
The same.
Same, except for one. Good. So not on the graph till 0, and then draw this on the graph till 0. Nothing done. Make sense to everybody? Okay, great. Okay, our next new function is called the reciprocal function. And like the quadratic function is called a parabola, the reciprocal function is called a hyperbola. Okay, for interest's sake. So the parent function is y equals 1 over x, or f of x equals 1 over x. And again, I left the x column blank because I'm going to pick certain values. So I'm going to pick them from negative to positive. So we're going to start off with -5. And reciprocal function, so y equals 1 over x. If x is -5, it's going to be 1 over -5. Does everyone see that? So that's -1/5. It doesn't matter where you put the negative sign. So let's imagine plotting that. So -5, 1, 2, 3, 4, 5, and -1/5 is going to be pretty close to the x-axis, but just below. Do you agree with that? -1/5, okay, just below the x-axis. And then let's try -2. So that's going to give us 1 over -2, which is -1/2. So that's easier to plot. So -2 and -1/2. -1. 1 over -1 is -1. So -1 is here. -1/2 I'm going to use for x. Going to see what happens. So y equals 1 over x, which is 1 over -1/2. So how do I do 1 over -1/2? We did this kind of in our first day with function notation. How do I divide a whole number by a fraction? Multiply by the reciprocal. Okay, so it's going to be 1 times -2 over 1, which is -2. Okay, because the bottoms are 1s. Try it on your calculator. 1 divided by -0.5. Or 1 divided by a bracket, -1 divided by 2 bracket, it's going to give you -2. So look at where you plot that. -1/2 is here. -2 is here. So it's going to be right in there. -1/5. See what happens if I put -1/5 in inside. See if we can figure out what we need. Anyone think they know? -5? Okay, does anyone know what the word reciprocal means in math? What? So when you put -5 in, you take the reciprocal of -5, you're gonna flip -5, it doesn't equal it, but the reciprocal, I'll put RUC over here, would be, because the denominator is 1, -1/5. If I put -2 in and take the reciprocal, I get -1/2. If I put -1 in and take the reciprocal, sorry, I would get 1 over -1, which is -1. If I put -1/2 in and take the reciprocal, I get -2 over 1. Okay, so I'm just flipping it each time. So -1/5 and -5. So -1/5 is just a little bit to this side of the y-axis, and -5 is 1, 2, 3, 4. So that's where my point would be, like almost, but not quite touching. Okay. So what if I put, don't put this in your chart, but what if I were to put -1/10 in? Don't put it in, but what if I were? What would the reciprocal be? -10. So -1/10 is even closer, and I'm going to be down at 10. What if I put -100 in there? So -100 is so close, like on this grid anyways, I can't even see it. I'm going to be all the way down at -100. Okay? What if I put 0 in? Is division by 0 possible? No. So I can't ever touch the y-axis. Okay? And then let's think about going this way. If I were to put -10 in, I'm going to get -1/10, so I'm going to be even closer to the x-axis. If I put -100 in, I'm going to get 1 over -100, which is even closer to the x-axis. If I put -1,000 in, I'm going to get -1/1000. Okay? Am I ever going to touch the x-axis? No. So you draw in what's called a hyperbola. So I usually start from the -1 spot and try to draw so it looks like I'm getting closer and closer and closer to the x-axis, but not touching it. And then same thing here, I want to make it look like it's getting closer and closer and closer to the y-axis and not touching it with an arrow on the end. But all I've done is up to, I've gone from, say, -infinity to 0, but I want to keep going. I know 0 is not an option. So then I'm going to start at +1/5. So if I put +1/5 in, take the reciprocal, I'm going to get 5. So 1/5 is like really close to the y-axis, and then up to 5. Here. If I put a half in, I get 2 out. If I put 1 in, I get 1 out. If I put 2 in, I get 1 over 2 out. And if I put 5 in, I get 1 over 5 out. So I've got the same thing happening up here. So start at 1, 1 and go upward, looking like you're getting closer and closer and closer, but not touching. And then downward. And then we're going to add in our asymptotes. These are like our guardrails, showing that we always stay above or below them. This asymptote is along the x-axis, so it has the equation y = 0. And then this asymptote is along the y-axis, so it has the equation x = 0. So that is what the reciprocal function looks like. It's called a hyperbola. So do its domain and range. Anyone think they know it? Domain? Yep,
Every real number as long as x is greater than 0.
very good. Every real number except 0. Okay? And the range check?
It's the same.
Yep, except for it's 1. Every real number except 0. Very good. Okay, the last new one is the absolute value function, but before we do that, I'm going to show you a video, and I apologize, the speakers in my room don't work, so we're going to hear it just from my computer. So put it on maximum, we'll just be really quiet. But it's a really good little video on what absolute value means, really easy to understand.
Hey, this is Professor Perret. Today we're going to work on absolute value, poetry, formula, radio.
That's all you need to know. Okay, so I don't seem to turn the lights on. All right, so definition of absolute value. The absolute value, we'll go back and fill out the graph in a minute, of a number is its distance from 0 on the number line. And the symbol are these bars. And in BEDMAS, absolute value bars have the same, I'm going to say weight, or in the hierarchy, they're the same weight as brackets. Okay, so brackets, you do brackets first. And so you do absolute value. Where you would multiply what was exponent. Do an exponent, etc. Okay, so now we'll go back and do our absolute value function, see what it looks like. So the absolute value function, which I call the V, going to give you an idea what it looks like. The parent function is y equals the absolute value of x, or f at x is the absolute value of x. So I'm going to do -2. So again, if I was doing y equals the absolute value of -2, that would be 2. Absolute value of -1, this is from -1 to 0 on an underline. 1. Absolute value of 0. Absolute value of 1. And absolute value of 2. 2. And if we plot these, you're going to get this V looking. Absolute value of -3 would be +3, etc. And you've got this V you can draw in. And then you join it, the ruler preferably. Arrows on the ends. And then see if you can determine the domain and range. What do you think about domain? Always on the graph? Always? So all real numbers? And our range, down here we're not on the graph until 0, and then we're always on the graph. Okay. Great, we'll do a few absolute value calculations now. Evaluate each expression. So the absolute value of -27 would be the distance from -27 to 0 on the number line, so 27. This is the absolute value of -3 minus the absolute value of -4. So the absolute value of -3 would be 3 minus the absolute value of -4 is 4. And then what's 3 minus 4? -1. So we did the brackets first, okay? Brackets first. This case, we're still going to do the brackets first, but in order to do these absolute value bars, I have to do what's inside first, okay? So I still have my absolute value bar, because I haven't taken the absolute value yet. -5 minus 4 is -9. Now I'm going to take the absolute value of -9, and it gives me 9, okay? And then this one, when there's more than one absolute value, it can look confusing. So one thing I used to do was, here's an opening absolute value and a closing one, and just make them like that so I could see where the absolute value bars corresponded to, okay, if it looked confusing. So they have the same weight as brackets in BEDMAS, so I'm going to look first at my absolute value bars and see if there's something to do inside of them. Is there? Yes, a subtraction. So I still have my absolute value bar, but I'm going to do that subtract inside. 12 minus 17 is -5, minus 3 Here's my next set of absolute value bars. There isn't an operation to do inside, so I could actually just take the absolute value of -4 right now, which is 4. So now that I've taken the absolute value, it's just going to go in regular brackets because it's right beside this 3 here. Okay, so I can't just write down 3, 4, or it'll look like 34. Okay, so this is going to be multiplied. So now in my next time through, I can still do the brackets. I can take the absolute value of -5, and then this is a multiplication, so -12 minus 3 times 4, -12. And then 5 minus 12 is -7. If f at x is 2 absolute value of x minus 4 plus 3, find each of the following. So this is back to using function notation from our first day, except now we can use an absolute value because we know what it means. Okay, so f at 7 would be 2 absolute value of 7 minus 4 absolute value bar plus 3. And then you know how absolute value bars work, they're with brackets. So we're going to do inside the absolute value first. 7 minus 4 is 3. F at 7. So now I can do the absolute value of 3 is 3. And then 6 plus 3 is going to be 9. Okay, so see if you can do the f at -5 one. Okay, so lots of people substituting in -5 for x, which is great. Integers, that would be -9 inside the absolute value bars. Then you take the absolute value of -9, which is +9. So it's going to be 18 plus 3, which is 21. Okay? All right, so that's our first lesson. So what I'd like you to do is fill this chart out so that you can have it handy. You can rip it off and just have it handy for when we start doing transformations. So what this is going to be is a summary of each parent function. So I want you to, if you want to put the table of values here, you can. I want you to draw it perfectly, okay, not just approximately, and then put the domain and range here, and do that for each parent function that we're going to be using for transformations. Okay? So you can rip it off and then recopy them. And then I also have a few absolute value calculations, but not many. I made a full sheet, but I don't want you to do that many of them. Most of today we're going to spend on learning transformation.